All right, everybody. Today we are starting 11.6. We're going to be talking about properties of chords today. Now, I want you to picture this in your head. This is the second to last geometry lesson. Second to last geometry lesson. Well, before we start the final review. But second to last geometry lesson in chapter 11. And after chapter 11, geometry's done. Wow, you guys have come a long way. All right, so let's get started on this 11.6. We're going to be using properties of chords in a circle, which means we get to write a theorem. If two secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. Okay, pause now, write this down, and then I will explain. All right, notice that this is quite a bit different than an inscribed angle because this is not an inscribed angle here. Notice that my angle of AEC here, or AEB, whatever you want to call it, is not on the edge over here. That's what makes it a non-inscribed angle. So because of that, we have to use this formula of the measure of angle 1 is equal to half of arc of AB and plus CD. I use their intercepted arcs, which are AB here and CD here. Those are the intercepted arcs of AD and BC. Okay, so I add those two intercepted arcs, add them up together, divide by 2, and I get my measure. All right, let's try a few. All right, so we have measure of angle AEB on this one. All right, so we're going to find each measure. If you think you have an idea of how to find it, give it a shot. If not, I will explain in just a moment. Pause now. All right, now that you have drawn that circle, what you have to do is you take angle AEB, and we're going to set that equal to, again, remember we need to take half of the intercepted arcs. Well, the half of AEB here, its intercepted arcs are AB and CD. So I'm going to be taking the measure of AB plus the measure of CD, and that's going to be my angle measure. So I take half of, what's AB? 139 degrees plus 113 degrees. Add them up, and I'm going to get half of 252 degrees. When I take half of that, I get 126. Wow, I did that pretty darn quick. Okay, so I add up the intercepted arcs, add those up, divide by 2, you get your angle. All right? Sweet. Moving on. Very quickly, I want you to give this one a shot. I want you to find the measure of RNM. RNM. Think about what you know about certain angles. All right? Give this one a shot. All right. So if I look at this measure, okay, RNM, I know that RNM is right here. Now, do I have the intercepted arcs measures? No. I don't know what MRR is, nor do I know what QP is. Okay, could I figure them out? It'd be very, very difficult. But I can tell you this, I can easily find RNP, can't I? I can find that angle. Yeah, how do I find RNP? Well, use the formula we just talked about. All right? Then from there, how in the world would I find RNM? Think about that a little bit. If you think you know how to do it by finding RNP first, I want you to give it a shot. If not, I want you to try to find RNP first, and then we'll move on from there. So pause. All right, so now what I need to do is I need to find RNP. How would I find angle RNP? Well, I just take half of the intercepted arcs, which are the measure of RP, plus the measure of MP. Q. Okay, when I do that, I take half of 91 plus 225. And that's going to equal, when I take half of that, altogether it's going to equal 158. Whoops, what am I doing? 158. 91 plus 225 is 2, sorry, it's not 216, it's 316 divided by 2 is 158. Then what I have to do, now that I find this RNP, how could I figure out RNM? Well, if you remember this from all the way in, I believe it was chapter 1, possibly chapter 2, these two angles are called starts with an L, linear pair. So when they are linear pair, it also is supplementary. The angle of RNM is equal to 180 minus RNP, which is 158. And you will get 22 degrees. Sweet, so RNM, 22. 22. All right, moving. Next theorem comes from two chords. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of the chords are equal. So before we were talking about angles, now we're talking about lengths of segments. So you take the products, so the multiplication problem, multiply them together, and they're equal. All right? All right. Here we go. Pause now if you haven't finished this. If you haven't finished this, we're moving on. 3, 2, 1. Go. So it says find the value of x. So if you remember that formula that you just talked about, I want you to see if you can give this one a shot if you would like to. Otherwise, I'm going to explain it. And I'm talking really, really, really fast. But I want you to be able to show your work on this one. It may be simple, but I still want you to show your work if you know how to do this. All right? So pause now. Give it a shot. All right. If you're not sure, this 7 is with JF. This X is with JH. So when I do this, I need to take FJ times JE, and I'm going to set that equal to GJ times JH. Because we know that if we have two chords that intersect, in order for me to find the lengths of their segments, we take the products of the two segments and we set them equal to each other. So we know that FJ is 7. We know that JE is 10. We're going to set that equal to GJ, which is 14, JH, which is X. When all is said and done, we get 70 is equal to 14x. We're going to divide by 14 on both sides, and x is going to equal 5. Now, am I done? Yes. But I'm done finding x. Okay? We also need to find the length of each chord. So length of each chord. So my chords in this scenario are GH and FE. So when I do that, GH is equal to, well, I know that GH is 14. I know that X is 5. So I take 14 plus 5 and I get 19. I know that FE is equal to 7 plus 10, which is 17. They're not going to be equal all the time. Sometimes they may, but sometimes they won't. So just know that you set their products equal to each other and then you solve. All right? Here you go. Here is the last slide of the day. I want you to find the value of x and then the length of each chord. Sorry that I'm not crossing that out. I am underlining it. Underline, underline, underline. So pause now. Give this one a shot. All right, so we know if I look at this, I plug in, I multiply the two segments together. On one chord, multiply the two segments on the other chord, set them equal to each other. So I need to take AE times EB is equal to DE times EC. That's 6 times 5 is equal to 8 times x. When I do that, I get 30 is equal to 8x. That's not going to be pretty. It's going to end up being a decimal, and x is going to equal 3.75. It's okay if it's a decimal. Then, I now have x. Am I done? No, because I also need to figure out, I'm done with finding x. So yes, I am done finding x, but I'm not done with my problem. I need to answer both questions. The lengths of each chord. What are the chords? DC is one. AB is the other. Solve for DC. Well, DC is 8 plus x, which is 3.7. So 8 plus 3.75 is equal to 11.75. AB is equal to 6 plus 5, which is 11. And we're done with this problem. All right. So I think today was a relatively quick lesson. I want you to do the assignment tomorrow when you get back to class. So I hope you enjoyed this lesson, because all math lessons are wonderful. I know you're just waiting to get going every day. But have fun with this, and I will see you later. Have a good day. Bye.